Welcome back to your channel name, where we explore the fascinating world of artificial intelligence. Today, we're diving into the realm of clustering algorithms in machine learning, a powerful tool that helps us uncover hidden patterns in data. Whether you're a seasoned data scientist or just starting your AI journey, this video is for you. Hi, I'm your name, and in this video we'll explore what clustering algorithms are, how they work, and their real-world applications. By the end, you'll have a solid understanding of this essential machine learning technique. Clustering is an unsupervised learning technique that groups similar data points together, allowing us to identify inherent structures within the data without prior labels. Think of it as sorting a mixed bag of fruits into baskets based on their types. Apples in one, oranges in another, and so on. One of the most popular clustering algorithms is k-means. Here's how it works. Initialization. Choose k initial centroids randomly from the data points. Assignment. Assign each data point to the nearest centroid. Update. Recalculate the centroids based on the assigned points. Repeat. Repeat the assignment and update steps until the centroids no longer change. This iterative process helps in partitioning the data into k distinct clusters. But k-means isn't the only clustering algorithm out there. Let's take a look at a few others. Hierarchical clustering builds a tree of clusters by either merging smaller clusters into larger ones, which is called agglomerative, or splitting larger clusters into smaller ones, known as divisive. Then there's DBSCAN, or density-based spatial clustering of applications with noise. It identifies clusters based on the density of data points, effectively handling noise and outliers. Lastly, we have Gaussian mixture models, or GMM. This algorithm assumes that data points are generated from a mixture of several Gaussian distributions, allowing for clusters of different shapes and sizes. Each of these algorithms has its strengths and is suited to different types of data and problems. Clustering algorithms have a wide range of applications across various industries. Customer segmentation. Businesses use clustering to group customers based on purchasing behavior, enabling targeted marketing strategies. Image compression reduces the size of images by grouping similar pixels together, maintaining quality while saving space. Anomaly detection identifies unusual patterns in data, such as fraudulent transactions or network intrusions. Let's see clustering in action with a simple example using the k-means algorithm. We'll use the popular Python library, scikit-learn, to implement k-means clustering on a dataset. First, we'll import the necessary libraries and load our dataset. Next, we'll initialize the k-means model with the desired number of clusters and fit it to our data. After fitting the model, we can visualize the clusters to see how the algorithm has grouped the data points. As you can see, the algorithm has successfully identified distinct clusters within the data. In summary, clustering algorithms are powerful tools in machine learning that help us uncover hidden patterns and structures in data. Whether you're analyzing customer behavior or detecting anomalies, understanding these algorithms is essential. Thanks for watching and see you in the next video.